Good morning, student. See, today I shall solve the questions from exercise 1.1 from the very beginning, that is from question number 1. Okay, question number 1, first you read the question nicely. What is the question here? Determine whether each of the following relations are reflexive, symmetric and transitive or not. Okay, and here the value of A is, the set is given and the relation is also given. Okay, so first question, let us start to solve from question number 1. What is given? Given set is A equal to 1, 2, 3, 4 and lastly it is 40. What is the relation R? The relation R is x comma y such that 3x minus y equal to 0. Okay. Now you see the set which is given in the question, that is in the roster form, but the relation R, it is not given in the roster form. So remember, whenever we shall try to examine or we shall try to determine whether the set is reflexive, symmetric or transitive or not, we have to convert it in the roster form first. That means the value of x and y will be visible. Okay, so we can write one more line from here, that is x comma y. What is the value of this one? This is 3x equal to y. Now let us put the value of x. We shall get the value of y, because the value of x, these are the, remember, these are all the values of x and these are the values of y also. These are the values of, but whenever we shall start to put the value of x, we shall start to put the value of x from the beginning, and the value of y that we shall obtain, that will be also lie in this set. If it cross the set, we should stop here. So let us put the value of x. 3 into 1, 3. That means when x is 1, y is 3. If we put x equal to 2, y is how much? 6. If we put x equal to 3, y equal to 9. If we put x equal to 4, y equal to how much? 12. Now if you put x equal to 5, because 5 is lying here also, but y, in that case, what will be the value of y? The value of y will be 15 and it will not be lying in this set. That means we cannot take that value. So how many values are there in R? There are 4 values. Okay. So what is the definition of reflexivity? Last time also I told you that definition of reflexivity means if we consider any element from the set A, if the doublet belongs to R, then only it will be reflexive. So if we consider the element 1 from the set A, we will see that 1 comma 1 does not belong to R. That means it is not reflexive. We don't need to go for the second element, because the condition is not satisfied by the first element. So if you do not go for the second element, no problem. If after taking the first element, if it satisfies the condition, then only you will search the second element. Okay, so 1 belongs to A implies that 1 comma 1 does not belong to R. So R is not reflexive. Next, if we consider 1 comma 3 belongs to R, if the element 1 comma 3 is taken from the relation R, 3 comma 1 does not belong to R again. 3 comma 1 does not belong to R. So R is not symmetric. So R is not symmetric relation. So R is not symmetric. Next, we will see whether R is transitive or not. If we consider 1, 3 and 3, 9, why I am taking these elements? Because only these two elements are satisfied the conditions. The conditions are satisfied by these two elements only. So we shall consider 1, 3 and 3, 9 only. So 1, 3, 3, 9. We shall first take only those elements such that they are satisfying the conditions. So if you consider the common element 1, 9 does not belong to R. This is implies that 1, 9 does not belong to R, so R is not transitive relation. R is not transitive. Okay, so easily we can solve these types of questions whenever we have to determine whether the relations are reflexive, symmetric and transitive or not. Okay, so let us do one more sums. Let us do question number 2 now. Question number 2. What is question number 2? Question number 2, the given set is question number 2. 1, 2. Given set is n equal to 1, 2, 3, 4, 5 up to infinity. What is the given relation? Given relation is how much? X comma y such that y equal to x plus 5, and here the value of x, it is less than 4. The value of x is less than 4, that means we cannot take more than 4. That means we have to stop at 3. So let us put x equal to 1 first. If we consider x equal to 1, y equal to 6. If we put x equal to 2, y equal to 7. If we put x equal to 3, y equal to 2. So only these 3 elements are there in the relation. Only these 3 elements are there in the relations. Now we shall search whether this relation is reflexive or not. So very simple, it is not reflexive because 1 is in n, but 1, 1 does not belong to R. 1, 6 belongs to R, but 6, 1 does not belong to R. So it is not symmetric. For transitivity, what are the conditions? That second element of the first pair and first element of the second pair should be same. But these conditions are we cannot take these types of elements from the relation. So definitely it will not be a transitive relation. Here 1 belongs to n implies that 1, 1 does not belong to n. R. So R is not reflexive. Next, 1, 6 belongs to R implies that 6, 1 does not belong to R. 1, 6 belongs to R implies that 6, 1 does not belong to R. So R is not symmetric. Now we shall see whether this relation is a transitive relation or not. Okay. So see, if we want to go for that, whenever you take the elements from the relation, you have to take 2 elements. And how the element should be considered? Second element of the first pair and first element of the second pair should be same. If we can take these elements, then we shall cancel the common elements and the remaining two elements must be in R again. But what will happen if we cannot take these types of elements? Because it is not necessary that second element of the first pair and first element of the second pair will be in R. Okay, so if we cannot take such elements, remember the relation will be automatically a transitive relation. Because I am just giving one example. If you appear an exam, if you can sit, then only question will come whether you will fail or pass. But if you cannot appear the exam, if you have not appeared the exams, then what will happen? You will fail or what? No. Suppose in the second year class you have taken physics, chemistry and biology. Physics, chemistry and biology, but you have not taken mathematics. So when the result will be declared, everybody will say or what? That you have failed? No. If you have passed in physics, chemistry and biology, means you have passed. You did not take mathematics, that does not mean that you have failed. Okay, if you take it, if you appear it, then only question will arise that you will fail or pass. Okay, that means if we cannot take such elements, we cannot take the elements according to the definition of the questions, then automatically it will be a transitive relation. Okay, so what is we shall write here? Since A comma B, B comma C, you just write, since the elements of the form, since the elements of the form, since the elements of the form A comma B and B comma C are not in R, so R will be a transitive relation. Transitive relation. Finish. In this way we can determine whether the relations are reflexive, symmetric and transitive or not.